a method that tries to change the, okay? In fact, there's even no such method called today we started looking at some data structures in Python. Specifically, we've looked at lists and tuples. And in today's class, we'll probably look at dictionary because this class is a data analysis class, but because it's not practical for us to begin data analysis unless we see the basics of Python. So we'll not go deep into, we'll not treat everything in Python. If not, we'll spend the whole 4 weeks teaching Python without even treating learning Python is one thing, and then learning data analysis with Python is another thing. We usually have 2 separate classes each 4 weeks, but here I'm trying to force merge everything together. So some things are not so, I'll just mention them, and then it's up to you to go and so we'll continue from tuples with dictionaries. So we know what these are, we know what tuples are. We now have another type of data structure called dictionary. Even though I mentioned it earlier, that if you want to make a list in Python, you use the normal bracket as a square bracket. If you want to, sorry, the square bracket. If you want to create a tuple, you use the normal bracket. Well? If you want to create a dictionary, you use the curly bracket, isn't it? But then, in creating a dictionary, as opposed to having one element, just the way we have 2, 4, 6 in list, every element has 2 things. There's a key and a value. Okay? Every element in a dictionary has a key and a value, and that's why it's called a key value pair. Okay? A dictionary is a key value pair. That's the simplest definition in Python. Okay? So similar to actual dictionaries, they are effectively 2 lists combined. So it's like we're just combining 2 lists together. One is the list and one is the dictionary. I don't know whether this will make sense. Let me create 2 lists. Let me create 2 lists. I call this names, and I say this is Abdul, Bello, Charles, or Charlie, and then D is Jenga. I call this age. You see, Abdul is 20, Bello is 45, Charlie is 44, and Lola is 22. So what has happened here? I created 2 lists, isn't it? One containing what? Names of 4 persons, and then the other list is age containing their corresponding ages. We are now saying in Python there is a more elegant way of doing this. So as opposed to saying names, ages, as opposed to having the names in one variable and the ages in another variable, you can just have a singular variable, maybe name ages, name ages, eh? Maybe name and ages, no? This is just a way of, this is just my own way of calling it. Call it the way you like. So in this, we are going to have a dictionary that contains for every person the name and the what and the age. And how do you create a dictionary? We use curly bracket. Okay? We use curly bracket, and then, like I said, a dictionary is a key value pair. A dictionary is a what? It's a key value pair. Key value. Every element is a key value. And we separate the key and the value by column. Okay? So we say Abdul, the age is what? 20, isn't it? That's one element with a key and a value, isn't it? And then we have Bello, 45. Good. And then we have Charles, or is it Charlie? Charlie with 44. And then finally we have Dauda having 22. So what we have here is exactly what we have here, only that here we are having two separate lists, one keeping the list and the other keeping the ages. But here we are having everything all in one place, isn't it? So this is what we call dictionaries. Dictionaries, just like in your dictionary, if you want to look up the meaning of a word, what do? You alphabetically check for the key, isn't it? You're looking for the meaning, isn't it? You go and check for the word, okay, what's the meaning of Python? You go to PYT, you check for Python, then you look up the word of the meaning. So that's what happened. Now if I want to check the age of Abdul, I can simply call Abdul directly, isn't it? Alright? So if you do type, let me run this. If you do type names, what do you have? It's a list, isn't it? This is a list. Age is also a list, yeah? But what? Names is what? It's a dictionary. Any question?
Names, is it a particular term or you just?
That's a variable thing. Okay. That's a variable name. Okay. Just for me to see name and ages combined together. Okay, so let's go back to the slides. So remember, the key and the value are separated by what? By a column, isn't it? And the entirety of this is what? Is one element. So if I come here and I do learn, learn languages, what do I get? 4. Correct. I get 4. If I want it from the,
how did you even check the last thing you checked to confirm that the languages is a dictionary?
Type. Type is the function. Type, type, is the function that is used to check the data type of a variable in Python. Type, small letters.
So will it be type equal to?
No, it's a function. Type, then open bracket, then the name of the, then the name of the, okay. Okay, let's see something. If you want to get Abdul from names, how do you do that? Just a quick If you want to get Abdul, if you want to get the age of Abdul from here, what do? You do ages. You do ages what? 0, isn't it? That'll give you what? Sorry, it's not ages, it's age, right? You do age 0, isn't it? And that will give you what? 20, isn't it? So in a list. Yeah, for Bello. If you want to check for the age of Bello, that will be age 1. So in a list, if we want to check for something, we have no option than to use the index number, isn't it? But here, if I want to check the age of Abdul from the dictionary, I call the dictionary, isn't it? And then index what?
0.
Index Abdul. It gives you what? And this is why the dictionary is what? Is better. If you do 0, it will give you error. A dictionary. You want to check for the meaning of something. What do? You open the dictionary, you go to the word, and then it gives you the answer. So I have a dictionary here: Abdul 20, Bello 45, Charlie 44, Dauda 22. You for the dictionary, you say okay. You call the dictionary, and then you supply what? The key. What's the key? Abdul. And then you get what? You get the corresponding value. Any question? Okay, let's continue. So we use the keys to access the values instead of indexing them like a list. And each value is mapped to a unique key. Isn't it? I think it makes sense now. It doesn't make sense for two values to have the same key now, isn't it? So if we index the value, which key will it give us? For example, if you come here, even though this one way I think Python doesn't make sense to me, isn't it? If I come here and I say Abdul, and this is 77, if I run the code, it will not give me error. Okay? Even though I have declared 2 elements with the same key. But for 2 elements to have the same value, that one is not a problem, isn't it? Yeah? You can have 2 students having the same mark, or 2 students born in the same year or date, so it doesn't matter. But the most important is that the key should be unique. So here, if I call Abdul, is it going to call the first one or the last one? In your opinion? It won't give you error. It's going to give you the last one because that is the latest one. You know, programming in Python runs from top to bottom, left to right. So what you have at the right is an updated version of what you have. For example, if I come here and I say x is equals to 2, x is equals to 6, and I run this code now. Okay, sorry. I can use semicolon to separate codes. So this will run back. If I print x now, x will be what? X will be 6, because the one in the right is the most latest version, isn't it? So each value is mapped to a unique key. So just like we have this, if there's anything you shouldn't forget in dictionary is that they are key value pairs. They are key value pairs. A dictionary the element must be a key and a value separated by a column. That's the rule. So this is the formal definition. It's defined as comma separated key value pairs. Comma separated key value pair. So I have the first in my dictionary. It's key 1, val 1, key 2, val 2, key 3, val 3. So we have the curly bracket here to tell us that it's a dictionary.
Okay, for this dictionary, is it a curly bracket for you?
Yeah.
I just want to. I didn't want to distract you because I've been getting error in my.
Please, don't distract me because that's why I'm here.
Okay, that is why I'm getting error.
Whenever you use this, that's what? List. Tuple. Dictionary, if it's a key value pair. If it is one value, if it is just one value without a key value, it's a what? It's a set. We've not written set yet. This a list. This a list. This a tuple. This a dictionary. If it is a what? Key value, isn't it? And then if it is a set, if it is just one value, isn't it? One element separated by a comma, isn't it? It's clear. It's clear. Okay. So key value, we have this comma separated. So let's look at some dictionary properties. So values are mapped to a key. Values are accessed by their key. Key are unique and are what? Immutable, isn't it? Values cannot exist without keys, isn't it? So for example, let us define the one from the previous page, isn't it? That's where we showed this guy, where we showed this. If you want to define this particular dictionary, what do you have? You have open curly bracket. Monday is a string, so it has to be in quotation mark. That's the key. Then colon, then the value given in it. Tuesday, diamond, Wednesday, Thursday. So we can paint the type of this, and that will be a dictionary, isn't it? Dict. And if we want to access the dictionary, unlike when we used lists that we use the index 0, 1, 2, 3, 4. In this case, we use what? We use the keys to get the values. So note that it can't be indexed like a list. And just like we have list methods, string methods, yeah? If you do, if you come here and you do their str, what do you get? You have all the list of methods that can be called on a string. Okay? If you do their list, you have all the list of methods that can be called on lists. If you do their tuple, you also have all the list of methods that can be called on a what? Not tuple. In a similar manner, if we do the dict, okay, it lists all the list of methods that can be called on what? On a dictionary. As you can see, we have only a few of them: clear, copy, from kicks, get, items, pop, etc. So for example, altering a dictionary can be done via the dictionary methods. For example, we can update. You've seen it here. Update. Where is it? Here. Huh? So what does it do? It updates what? The dictionary, isn't it? In your opinion, update, is it similar to what's the analogous method in list?
Append.
Append. Very good. Append. Okay. So you have days of update. So in the original dictionary there was no Saturday, but we now updated with Saturday together with its corresponding value, isn't it? And now if you print this now, it will be inclusive of Saturday. What of pop? We've also seen pop in lists. Pop, it removes the last element and then pops it out for you to see. How can you? In list. Yeah, we didn't look at it, but I think I verbally said it. For example, if I have, let's see, x is equals to 1, 2, 3, 4. Isn't it? You run this, you don't say, we don't like 4. What do? You can just say x dot what? X dot pop, isn't it? And when we do that, what happens? It pops out the last element and removes it, isn't it? So if you call x now, you see that it is devoid of 4. So the same thing happens to the pop in dictionary. Okay?
Okay, I thought it was just to see.
It will pop it up and release it. It doesn't like, so it goes. So just like what we have here. We updated the dictionary with Saturday and Saturday, and when we printed it, it's now Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. We now popped it, and what happens? When you pop it, when you pop Monday, you see that, and you print the days, it removes Monday from the list, so it starts from Tuesday, etc. Okay? So keys and values, apart from the update, there's also keys and values. I think there are these values, and then these are keys. I think this is intuitive. The keys is used to get only the keys of the dictionary. You have a dictionary, you want to get only the keys. You use the keys method. If you want to only get the values, you use the what? The values method. So this is useful for iteration. So we also have, please you can look at the other methods, get item, etc. Set is also another type of data structure, though it's not so useful for. So it's effectively lists that can't contain duplicate items. If you look at it, it's like everything emanates from the list, isn't it? Yeah. We said a tuple is a list that is what? That is immutable. A dictionary contains 2 lists. Because ordinarily you can have a list for the keys and another list for the dictionaries. So if we have a unified dictionary that contains both the keys and the values, say it's a dictionary. Then what again? Now we have set. Now set are effectively lists that cannot contain duplicate elements. A list can contain duplicate elements. A list can contain duplicate elements, but sets cannot contain duplicate elements. But they have similar functionality to lists. And then it can be indexed or sliced. Okay? This is a bit more stricter than tuple. A tuple can be indexed, but cannot be sliced. It can be sliced. It can be sliced. It can be indexed. It can be indexed and sliced, but it cannot be changed, isn't it? But this one, it can be indexed nor sliced, and it's usually created using the what? Using the curly bracket. So you see, when you have curly bracket, but you only have one element. That's a what? That's a set. So for example, we have x equals to set 1, 2, 3. So you can create a list and then cast it to a set, or you can just use the one directly, isn't it? You understand?
How do you change from a list?
This one.
Yes.
This one. 1, 2, 3, 4.
Yes.
It's using the normal square bracket now.
Okay.
So it's a list.
Yes.
But because we casted it with a set, you now say set. So it's now converted to a
it's
set.
not just with the quality, you have to cast it with the sets.
But if you don't want to cast it, if you want to create it directly as a set ab initio, then we use what? We call it bracket, just like we did for y here. So this is the business of the if else statement. So if else statement, I think with these data structures we have enough arsenal we have enough weapons in our arsenal to start looking at some interesting things. So let's look at now conditional statements. Okay? You know, programs run from what? From top to bottom, isn't it? But if you want to now write a condition that only run this code if this condition is met. Okay? Yep. I want you to run this code, but before you run it, check that this condition is true. That's when you use if statement, isn't it? For example, if I come here and I say, print Python. Okay? If I run this, it prints Python, isn't it? But if I write a condition that, okay, I want you to print Python, but before that, check if x, okay, check if 4 is greater than 6. If it is greater than 6, then what? Print Python. Exactly. So check a condition. If that condition is true, do something. And look at the syntax. It is if. Maybe I should write this explicitly, because it's very important. You say if then a condition then colon, isn't it? Then we leave 4 spaces. That's a tab, isn't it? 4 spaces, isn't it? Do you understand? Then we have our code here, isn't it? Some code. Okay? We have if some condition. This is important. If you didn't get it, if, that's number 1. Number 2, what? Some condition. And we've looked at conditional operators earlier, isn't it? Greater than, less than, equals, less than, not equals to. So it means this condition must return what? This condition must return either true or what? Or false. And after the condition, we have this colon. And then after the colon, the next line should come in indentation, isn't it? This one is indentation, okay? Indent. Okay? That's 4 spaces. Then some code. So what we are saying is that this code that we have here will only execute if this guy is true. If this condition is false, then this guy will not. That's the guy inside the what? Inside the indentation. Hmm? Classwork. What will be the output of this code? If I know? If I run this code, what do you think will be the output? Hmm?
Print.
4 is not greater than 6. So the one program will not be JavaScript.
So that's it. We have our if. We have our if.
Yes.
Then we have our condition. Then we have our colon. Then we have our indentation, right?
Yes.
Here. 4 spaces. Hmm?
Yes.
So it means what's the body of the if statement? Is these guys, right?
Yes.
These guys inside indentation, they are the ones that have business with the if statement. This guy here has no business with the if statement.
Yes.
Its only business is finish whatever you're doing and come and run me, isn't it?
Yes.
So it will only run what? It will only print
Python,
Java.
Python.
It will only print JavaScript.
Oh,
Something
but why?
I don't get it.
Okay.
I'm confused.
Okay. You see, this is an if statement. You said if
Okay, because it is false. Okay.
if
Yes,
if
yes, I understand.
condition colon the body of the if statement. Huh? We now say this, the body. What's the body? Is these two guys, because they are the ones that are indented. These guys will only be interpreted by the interpreter if this condition is what? Is true. But is 4 greater than 6? That's false. So because 4 is greater than 6, then the if statement will ignore whatever is inside the what? Inside the indentation. And go ahead to the next line. And what's the next line? Is print JavaScript. So it prints JavaScript now. But if I come here and I say is 4 greater than 2? Okay, it's clever. But there is, if you notice, there is if I run, what of this? If I run this, what do you think will happen? Hmm? will print is if this is true.
Yeah.
So it will execute from here to where? To here, right? It will start with this one. It will print Python and then check if this is more than 5. This is false.
It's false. So it will not print Java.
So it will not print Java. It will not go ahead and print what?
JavaScript.
And then print combination. It's clear. It's clear. But there is one problem with the. There's one problem with the. Okay. There's one problem with the if statement. It's a one-way thing. If it is, it just checks for something. If it is true. The if statement is a one-way thing. It simply checks for a statement. If the statement is true, it does something. If the statement is false, nothing happens. Huh? It simply goes to another line of code. Isn't it? But in life, in most cases, you check for a condition. If the condition is true, it does something. And if it is false, it does another thing. Isn't it? Is that okay? So to do that, you use what we call the if-else statement. Okay? The if-else statement. Look at it here. So this is the if-else statement. This is the if, and then you have a condition, isn't it? If this condition is true, what happens? It prints this one, isn't it? But if this condition is false, it what? It prints, it does whatever is here, isn't it? So for example, if I come here and I say, if, let me say, x is equals to what? 10 and y is equals to 20. If I say, if x is larger than y, print what? Print x is what? X is what? Is bigger. Else, print what? Print what? Y is what? Is that clear? So x is what? 10. Y is what? 20. So it checks if x is larger than y. Is this true or false? False. So if this is false, it ignores this and what? And prints this. So what happens here? If I do this, y is bigger. What if this is, let's say 100, it means what? This is bigger. What if I come here and I say, x is bigger, I am out, I'm outside. But if this is 10, it means what? Y is bigger, I'm out. It's clear, everybody?
If x is greater than y is equal to 20, so if x is greater than y, then print x is bigger. It didn't wrong. Then
Sorry, come again.
Plus, if x is greater than y,
let me delete this. Okay, I'm listening.
So I started with if should we continue? Okay. So if x is greater than y, which is not, then print x is bigger. It's
Else.
Yes, then else print
Y is bigger.
Y is bigger. Then still didn't.
Stop. Let me check here.
Yes, thanks.
Check the error message.
I've been seeing so.
Please allow him to debug the code himself. I'm not saying anything. To see that we solve the problem. X is 10, y is 20. If x is greater than y, are you seeing the error?
Yes.
What does it say? Programming is not magical. Just look at the error.
Okay.
It says it is expecting a colon after.
All my errors I've not been looking at. I've not been
Look at it. Expected error where? Colon. It's expected this line. Where?
It's mine.
Check the error message. After so there's an error. There's still if you run this one, it will still give you error. If you run it, it will give you error. So you expect error after else. Shift enter. It's clever. So my friend forgot to enter this. Okay? And then when he ran the error, it's showing him the answer, but he's confused. So what's the error? It says invalid syntax, isn't it? It's expecting a colon where? Here, isn't it? There is a colon that's actually here. Isn't it? So you can just come and just fix it. If you run again, it tells you that there is something here. You just come and fix it, and then it runs without any problem. Okay. No. It's part of what you are printing. Whatever you put here, if you run it, that's what it runs. Whatever you put, whether it's exclamation or anything, so it doesn't matter. Is that clear? Okay, so there's also what you call if, elif statement. The if statement is just one way. Okay? The if statement is one way. The if else, two ways. What if we have multiple ways? We use if, elif, however we want it, isn't it? So for example, let's say we say x is equals to, let me say score is equals to input enter your score, isn't it? Enter your score. And I'll say score is equals to float score. Now say if score is more than or equals to 70, you say what? Print what? A. Elif score is greater than or equals to 60, print what? B, isn't it? It's 50. This is what? C, isn't it? This is 45. This is D, isn't it? And then elif 40. If this is E, then we can come and say else. Okay. Hmm? And if score is greater than or equals to 0, huh? Huh? We say what? Print what? F, isn't it? Else. Hmm? Hmm? Print invalid, invalid entry, isn't it? Hmm? Do you understand? Just like what happens in the university, isn't it? Our grading system. What happens? Whenever your score is more than 70, whenever your score is 70 and above, it returns what? It returns an A. And then between 60 and 70, that's B. Between 50 and 60, that's what? Hmm? C. Between 45 and 50, that's what?
D.
Hmm? D. And then between 0 and 40 and 40. Between 40 and 40 and 45, D. Between 0 and 39 or 40, that's F. But why did we use this else invalid entry? Should in case somebody enters a value that is not a number, isn't it? So that the program will tell him that, okay, this is not part of what we want, isn't it? So for example, if I run this now, and it asks me, enter your score. I got 77. It says A, isn't it? Hmm? You run the code and you enter 66. It says what? B. If you run this, 55. C. Hmm? If you enter this and you say 46, D, isn't it? If you run this and you say 42 or 44, it says what? It says, okay. Equal. If I run this and I say you got 12, that's what? F. Okay, sorry. If you call this and you say F, cool. What if I enter an invalid score? Let me see. He wants to enter 34. He now entered 30, maybe 34, and then he erroneously entered RR. Then the program should say what? In fact, the error is not even going to come from. It will come from float. It cannot convert float to. It cannot convert this to what? To what? To float, well? Then it tells you that could not convert strings to what? Float. So what if you enter, let's say, a negative number? Hmm? Let's say -6. It says what?
Invalid entry.
Invalid entry.
So if sir.
Yes, sir. Go ahead.
No. I think I want to try something because I felt condition is a bit because you can say for let's use the last part we also have which is 0
0
square is
2.
greater or equal to 0. You can say 50 is greater than 0.
Okay,
So
it's a good question, but it's a good question that it makes sense, isn't it? But I'll explain that. The thing is, programming in Python starts from where? Top to bottom. Even here, when you check, if I run this one and I put 55, check the code. It's saying if the score is more than 50.
So it has to be greater than.
So, but if I run this, it will give me C, isn't it? it will give me C. Even though even here it says if the score is more than 0, isn't it? And the 55 is more than 0. So the thing is, programming starts running from top to bottom. And if the first thing, it checks the upper values. If that value is not correct, if it runs this one, if this is not true, it goes to the next one, isn't it? If this is not true, it goes to the next. If this is not true, it goes to the next. If this is not true, it goes to the next one, until it reaches the last. But as soon as, if this is true, it prints it, and then that's the end. Do you understand? If this is true, if this guy is true, it prints A, and then it will not bother coming down here. So that's why, for example, if you have a number 40, it checks whether 40 is more than 70. That's false. It goes to, is 40 more than 60? That's false. Is 40 more than 50? That's false. Is 40 more than 45? That's false. Is 40 more than or equals to 40? This is the only time when it is true. So it prints E, and then it will not bother coming down here, isn't it? So it's the flow from top to bottom that made it to be able to now capture all of these things.
So what if we had reversed this condition?
How?
Less than.
You start from the,
Zero.
you start from testing 0.
Yes.
Yeah, so that will not, it will not work. It will not work.
At all.
No. It will give you error. It will run. It will be syntactic. The program will be syntactically correct, but semantically wrong.
So that means.
Because if you start from here, if you start from the smaller, where is it? If you start from here, from the smaller one, somebody can get 90, and if you come and check is score more than 0, yes, 90 is more than 0, and it will say F.
Yeah, that's.
So that's why I say the flow is just logical.
So that means before you even start, you have to know what you want.
Yeah,
And
you're right. Yes. So apart from this, we can also have what we call nested if statements. You see?
Sorry, we've not clarified this early. You just said early.
Elif is used if you want to extend the capabilities of if statement. If alone is one way.
Okay.
If else, 2 ways. If you want to have multiple ways, you use elif. That's why I mentioned elif like 1 million times before.
Yes.
So it means you want to extend the if statement. That's else if. Else if.
Let me understand this. If we had said, let's assume that we had said, what was that? If the score without the elif, if the score is greater than 60, we just said if the score is greater than 60.
Considering only the 60.
Yes.
There is no need for the elif.
Okay, so we'll not be able to.
The if elif is one code of block all in one place, and only one condition will run. How many conditions do you have here?
Okay.
We have one condition, the second, third, fourth, fifth, sixth.
I get it now. So we are using.
If one of them is true, then all the other ones, even if they are 1 million, it will just go to the next one, to go to the next line after the else statement. It's clear.
I get it.
Yes. And the else statement is optional. It's not dole that you must have else statement. You can remove it, and your code will run. Even if you don't have the else statement. For example, if I have 54 and I run this, it gives me C without any problem. Yes. Oh, the if is it must. You cannot have elif without if. If must be there. You cannot have else without if. You cannot have elif without if. If is the entry point. Everything follows it. Is that clear? So let's now look at what we call nested if statements. Nested if statement. You know, that's what makes you a programmer. Your brain should be able to nest and yes, sir. Sorry? Okay, let me come and check.
Sorry, what was the last thing you deleted? The
else.
Okay.
I removed the else block.
Okay.
I said it's not mandatory that we shall check it then. It's running fine now. You say enter your score and you don't enter the score now. Enter the score now. Enter the score. You hit enter. You hit enter. See now. If you enter the score, you will not hit run again. For example, now, if you run the code, it says enter your score, you see 34. When you hit enter, you see F. If you want to run the code again, you run it, and then you see maybe 66. If you do 66, don't hit run again. You hit enter to see it.
That score is going to input.
Where?
The first line is also compulsory.
No, it's not compulsory. The input is just used to collect information from a user, isn't it? She's asking whether the use of input is compulsory or mandatory. I can come here and just say score is what? Score is 74, 75. I'll even delete this one. And I can just run it. Is that okay? Yeah, you can delete the input and just enter the number directly, isn't it? If the score is 75.6 and then you just run it without any problem. So you don't have to sir, if you don't want to use the input, you can just put the score directly here. If the score is 75 and then you have your if statement. So here you can just run and see your code. Okay?
That's we just said score. Enter. What did you?
Yeah, I said the input
Yes.
will request a user to enter something.
Yes.
Then you enter it and hit enter. If you don't want it, you can just write the score and assign the variable directly. Let's say score is 85. You are a guru. And then after 85, you have your if statement. You don't even need to cast anything. You know when we said score is equals to float score? Why did we do that? Because the input collects whatever it collects as a what? As a string. So we need to cast it before you perform any arithmetic operation on it. Whenever you use input to collect something from user, it comes as a string. So that's why we casted to a float. So do you know that you can perform nested statements? Let's say let me see score is equals to 100. Let me see gender is equals to male, and I'll say if okay, let me just put it there. Let me say you are a lecturer that has special consideration for female students, isn't it? So you said anybody that you know, here it's regardless of your gender, isn't it? I can come here and say I can see, here, I can see 12. Let me delete this entry. Here I can see if score, I can see if score is more than 30, print E. Wait, create that one. Look at this. Okay. So what happens here? I have another if statement inside another elif statement. Isn't it? I can come here and see else print f. Well, just make it simple because we've not introduced break. So I don't confuse some people. It's clear, no? So look at it here. Regardless of your gender, if you score more than 70, it's an A. If you score more than 60, B. More than 50, C. More than 45, D. More than 40, E. But when you score less than 40, we check that if you are a female. Cool? So we said if score is more than 30 and gender is equals to what? Is equals to F. Right? You say what? Print upgraded to E because you are a female. Otherwise, it's what? It's F. So let's run this now. Here we set what? Should we call input or just running like this? Should we call it input function?
Yes.
So that we ask for the gender. Huh? So you say score is equals to float. Floor is equals to score. Input. Enter what? Enter your score. Enter your score. And then gender, your score is equals to input. Enter your gender, isn't it? So that we don't say male or what? Or female. So look at it now. If I run this, what happens? It requires the user to enter what? If you get 55 and you enter your gender as male, it returns what? C, right? Even if you are a female, if you enter 55 and you are a female, it returns what? Still what? C. But if you enter this, if you get 39 and you are male, it returns what? It returns F. And if I run this, you got 28, 27, and you are female, you still get what? You still get F. Isn't it? But if you get above, let's say you got 33.8 and you are female, it says what? Upgraded to E because you are female. So this made possible using what? Using the nested if statement. We wrote another if statement inside another one. And look at the condition. The condition is we're using the logical operator, isn't it? To what? To extend the comparison operators. Here we're saying, check, okay, from here above, what happens? We believe that the score is less than 40, right? We're not sure, please. We know that the score from here is less than 40. So check if the score is more than 30. And the gender is, so this and means what? Both must be true before this guy can do what? Can be printed. Exactly. It seems some people are finding these tricks. Very clear. So let me ask one question. If I run this code now and I say 33, and if somebody wants to enter female, she now mistakenly entered small letter f. She's supposed to be upgraded, isn't it? According to the program, isn't it? If I put capital F, she's going to be upgraded to what? To E. But if when entering, and people can make these mistakes if you design software, 33, and then as opposed to entering F, I go small letter F. Instead of writing capital letter F, I go small letter F. If I enter this, it will still give F. She's supposed to be upgraded, but because she goes small letter F, how can you ameliorate this problem? Thank you. Another way. There is no free lunch. What is it? The free lunch theorem applies to programming. There is no one standard way of doing anything. He said you do what? Gender dot upper. So whatever is the gender, it converts to uppercase before comparing, isn't it? So if you run this, you can see 33, and you even put small letter f, and it will give you what? So what if mistakenly she enters hello? She enters female here like this. To give what? To give error, isn't it? Oh, sorry, it will not give error actually. Maybe let's say 33 and she enters female. It will not give error, but it will put what? It will put F. How can you solve this problem?
Define the input as working male and female so that.
No. I have defined it, Gashiba. If I come here, let's say enter your score 33, and your gender, I said male or female, but some people they have strong head. They go and put what? Female like this. Please, what's the solution as a programmer? How can you solve this problem?
Is to find a way to give put another condition that would not allow the person imputing to put more than one alphabet.
No.
Why? Or this.
Or can do use or. You can come here and say if gender. If you say if score is this and I cannot open bracket here, right? and now say copy this, go, isn't it? And now say or, I put what? Female, isn't it? Isn't it? This will work now, Abi? So even if she enters, okay, even if she enters female now, oh sorry, I have to run the code again.
Capital letter for my female.
Oh sorry, I put the L bracket outside, go. Understand, right? If I run this now, I say 33, and she enters female, it will still give what? Upgraded to what? But if I were you, I would not use this. If I were you, I would not do this. What will I do? Who can? I want something that's brainy that I would. Right, open the science.
We put comma female in bracket.
I want it here. Okay, open the science. What will I do? What's your name? Abdullah. What will I do here so that even if somebody enters female, it will give you? Look at it now. Look at it. What's gender? Gender is what the user enters, whether it is F or M or female or male, right? So why not Tinda Musanchewade, even if you shagi waki, if you are spelling female, you start with F now. So you just index the first. Abi? Do you understand?
There's F.
No. We want to only use F for comparison. Yes, but we know some people can enter female. So why not, even if somebody enters anything, we just go and carry that first letter.
And that's what I'm saying, that's the F.
So what will I do here? Here, what will I do here? Yusuf, what will I do here? What's gender? Is the string that you it's a string now. It's a string that the user enters, right? Then what do we do? Here it's happening. We are converting that to uppercase, right? And then here we are carrying the first one. Huh? You understand?
Which first one?
She enters.
Female hacker.
She enters female.
Yeah, hacker, we are taking
look at it. F. She enters female, but if I do dot upper, what happens? If I do dot upper, it means what? Watch now. It means capital female, but if I come here and I do 0,
print F.
Print F. It's clever.
So no matter what the person writes, as far as the person starts
with an F, yes.
Even she writes female.
If she made a mistake, write P. Female coordinate.
No. Yeah, but I like your. Even if she enters.
So the 0 is representing the F.
It's indexing now. The indexing. If you index anything, blah blah blah. If you carry the first one, 0, it's giving you the first one, right? And then -1 will give you what? The last one. Yes. So what's happening here? Okay, I close the bracket bar that I have not opened up. So just like he said, if I enter 33 and she enters family, maybe even if she made mistake and enter family, family and blah blah blah, it will still give upgraded.
I'm saying if she made mistake with the first letter.
Unless if she made mistake with the first letter.
How can we accommodate all the mistakes?
The last one is now.
No, that's the else now.
That's
the else. Now that's why we have invalid entry.
Okay. Yeah.
You saw F. Yeah. You couldn't use F. You saw.
No, it's right. Maybe you can come here and say gender is equals to male or female. If you want to do it the way you like, but so if you can come here and say if If gender, okay, hello? Look at it. If gender is not, if gender not in F, have you? Then what again? What's another alternative? No, we are going to convert to small letters now. We are going to convert to capital letters. So it doesn't matter. Let's say F, go. Capital F. Sorry, male, female. Then what again? Male.
Yeah, one, comma, female.
Female. Isn't it? And then here we come here and say, and that upper, isn't it? And just even leave this one. Okay. Okay. Yeah, that was it. That was it. I did this. So you can see, if gender not in male, female, male, female, we say what? Can you see not in? You say what? Print what?
Invalid.
Invalid. Print invalid. Invalid gender, isn't it? Gender, isn't it? So for example, if you now come here and you run this, you enter 33, isn't it? And you enter female, it gives you what? Sorry, no. Okay, you have to put M, huh? No. Okay, sorry, no. We'll just come here and where's the control one? What have I done here? I'll come here and see if gender dot upper. If gender dot upper not in male female, print invalid gender, isn't it? So you can come here and say what? 33. If I enter male now, sorry, female, it will say what? Upgraded to E because you're a female. If I run this, if I say female, it will what? Sorry, 33, and then female, it enters what? Upgraded to. But if I enter this and I say 33, you say female. Maybe she's from Kano. You say female. You say what? Invalid gender, something like that. It's clear now. I think it's already 4:10, so we stop here. You can take questions if you like. When you come to tomorrow, sorry, not tomorrow, Friday.
Friday.
We're going to continue. So we've treated all of this. If, elif, if, ll, elif, else. We're going to start with for loops. For loops while loop. We'll finish with looping. We'll finish with looping and conditionals and everything in that's with three, and then in week 4 we'll now treat the data analysis proper. I believe in week 3 you should have a good grasp of the fundamental Python programming concept so that you can start looking at. Any question?
Sir,
okay.
Please, can Microsoft Excel do these functions?
Yes, Excel.
Yeah, if you know Excel, you can do most of these things. Yeah. But it's more elegant in Python. For example, if I prepare my score, I have the column for score. I just write equals to if. After doing the sum and everything, maybe I have Excel that has the total score. Maybe the score is equals to some this column plus this column. I drag, I get the values. Then I'll go there and say equals to if that particular cell is greater than or equals to 70 A. If equals to if you continue doing but it's more elegant in programming than. Okay, so I think at this juncture, I'll call it. I'll stop sharing.